Hi there folks. In this video we're going to have a look at a Lee 6-cavity bullet mold, although if you look at the label it claims to be an 18-cavity. This is Lee's fairly new mold for buckshot, and it produces 18 triple-aught buckshot pellets. And triple-aught buckshot has a diameter, or at least it should have a diameter, of 36 caliber. 70 grains, and that would be with pure lead, although in this case I am not going to be using pure lead. I'm going to be using wheel weights when I finally get around to casting with this particular mold. So I haven't actually used this mold yet. I figured I'd give everybody a look at it before I got it all dirty and goopy from use. So you can see it comes in the box here. Now with these 6-cavity molds you have to buy the handles separate, so keep that in mind. If you order a set of these blocks and you haven't already had a chance to pick up the handles, you need to order those as well. So I've got a set of handles kicking around here. We got a sticker on here. It apparently was inspected by Shirley, made in the USA. Well, that would be sensible because I think everything that Lee makes is made in the USA. And we've got our instructions here, which it doesn't hurt to familiarize yourself with, especially if you haven't had a chance to use any of their products before. Especially important are the instructions regarding mold preparation and lubricating the mold, because these mold blocks are manufactured out of a fairly soft type of aluminum, and they can be damaged rather easily. So very important to prepare these properly before you go to use them. So let's have a little closer look here at this. Right off the bat I see something that I'm not entirely enthused with. You can see here there's a hole. The sprue hole is not exactly very round, and this one's got another chunk of metal in front of it. So I don't know who Shirley is, but if she's inspecting things and letting that out, I don't think she's doing a real great job. But anyway, I guess we'll try it first before we send anything back. Yeah, that's interesting, eh? Let's see, they machined that. They didn't take the entire piece off, so we've got a little lip there. Anyway, I guess we'll give it a try first before we pronounce it good or bad. And as you can see, it's actually a 6-cavity mold, but it produces 18 balls because each of these cavities is interlinked with a hole between the round balls. So you basically have to break these up when you're finished with them. So we've got all the this cross hatching on here, and that's basically to help the mold vent. It lets the air out. And the mold blocks, being aluminum, have these steel inserts in them. You can see there's a steel pin here and a steel bushing here, and that's to align the mold blocks, to align the two cavities together, or the two halves together, and to prevent wear. Now these are fairly shallow blocks compared to a lot of the other ones that I've seen. I think they're a little bit shallower. I could be mistaken. And we'll have a look at the other side. And this one looks a little odd too. The cross hatching that's on it appears to have been either not done, or the machine was going at a different speed, so we don't really have any cross hatching on this part here. That could be problematic for venting, but anyway, we'll see before we pronounce it good, bad, or indifferent. And let's put these back together again, and you can look at one of the other features that these 6-cavity molds have, and they have an aluminum sprue cutter, and that's kind of an interesting thing. Most molds have a steel or a cast iron sprue cutter, and the aluminum on this one is quite a bit thicker than you'd see on a steel one, and that's probably a good match because the heat dissipates at the same rate from both the mold blocks and from the sprue cutter. So then we've got this stop over here that the sprue intersects with, and it's got a little spring washer on the top, and that's important because it keeps the mold closed properly. If it didn't have that, because this is such a long piece of aluminum, it would flex up and you could have a gap when you filled it up, so that keeps it down flush. So it's important to lubricate around this part here because it's aluminum and this is against steel. That will wear prematurely, so that's going to be lubed up. And we'll need a little bit of lubrication underneath this pivot point here. It's also got a spring washer on it to keep it down tight. That's a nice touch. And I usually put some graphite on top of the blocks to help them close over smoothly without galling. So I'm going to have to take this mold and degrease it before I go to use it. The cutting fluid from the machining process would still be on these cavities, so I'm going to scrub it out with nothing more high-tech than an old toothbrush and some soap and water. And then we're going to smoke these cavities to make sure that there's a good layer of soot on them. And we'll lube the top, as I mentioned, the various points on the top. Then when the mold is prepped properly, I'll be able to start casting. I'll put some handles on this too. We'll get right back to this. Seems very critical with this mold to get the alignment of the mold to the pot just so. Have to get the lead to go right straight down the hole without any swirling around, so that it falls right to the bottom of the bottom cavity and then fills back up to the top. That seems to be the only way to get a decent fill out with this mold. It's a little bit slow, and very rarely do I end up getting complete fill out. But anyway, we'll see here what this worked out like. Now that's a reasonably good fill out that time. We got a couple of underfilled pellets there, but that's actually not too bad of a result that time. And the block is not being entirely great as far as dropping the pellets out. They want to stick to the cavities, so it takes quite a bit of wrapping on the handles to get the pellets to free up. And even then, there's usually a couple that you have to give a little poke with the handle to get them clear of the blocks. And in typical Lee fashion, the handles of course keep falling off. This is the thing with Lee products. They have a good idea, and then, you know, they build things in such a fashion that they're made to be cheap to produce, but you end up with things like handles that want to fall off on you all the time. And that's just annoying as hell. Well, when all's said and done, the mold does make quite usable pellets. They come in these connected strings of 3, which you can cut apart. I've been doing it with just a set of side cutters. It's a bit of a crude way to cut them apart, but it does work. If you were more fussy, you could use a knife and cut these apart. But I'm sure it makes very little difference as far as their performance as buckshot, because they're certainly not going to come out of the bore of the shotgun being round after they've been fired. They're going to come out slightly squashed anyway. So it's a pretty good production there. That bunch there was the first bit I did. I was just kind of getting used to the mold, and I'm sure this mold will pay for itself in short order, because buckshot is a pretty expensive thing to buy, either loaded or even just as pellets for loading. So I guess the next thing up after this will be to load up some shells with these and take them out and try them. So anyway, that's my initial experience with this triple-aught buck Lee mold. Not completely happy with it yet, but then again, some of it might be my technique. And the more you use a mold, the more you figure out what works with that particular mold. And hopefully that'll be the case with this. The more experience I get with it, hopefully the better I will be able to get it to perform. Anyway, thanks for watching, guys. We'll talk to you later.